Welcome back to another exam walkthrough. In this video, we're going to be going through 2024 October Unit 5, question 2, 4, and 6, and question number 9 and 10 from October 2024. And if you want to check the mark scheme out and the examiner report, you can go to the end of the video. So we're going to be doing these MCQs, and let's go right at it. So it says, during an earthquake, steel-framed buildings remove energy from the oscillation of the building. Which of the following is the reason for this? So here it says that there is removal of energy from the oscillation. And what could be the reason for this? And the reason would be that the steel is made from a ductile material. And when ductile material undergoes plastic deformation, you're going to have energy being removed from the oscillation. Now, this is directly from the specification. You can check this out in the spec. It's the last objective of your chapter. It's about plastic deformation and ductile material. So here the answer is going to be A. So make sure that you know the spec points very well and you're thorough with them. Now we're going to go to the next part. This is a very simple part as well. You can read the question, but they're basically asking you which is the correct graph that shows the correct relationship between A and X, where A is the acceleration of the mass and X is the displacement of the mass. So we know that A is equals to minus omega square X. So we can write it as Y is equals to mx. So here we should have a constant gradient, and the gradient should be negative, so that should be D. Okay. Alright, now next part we're going to go through is this one. It says a mass is hung on a spring. The mass is set into vertical oscillation with a frequency of F. The mass on the spring is doubled. What is the new frequency of the oscillation? So we know T is equals to 2 pi square root m over k. And when we write the expression for frequency, we're going to say 1 over 2 pi square root k over m. Everything kind of flips. So this becomes divided by 1, and these two are going to flip over each other. And then we know 1 over t is going to be just the frequency. So now we have a direct relation between the frequency and the mass that's hung on the spring. And now what I can do is I can say F is equals to square root k over 2 pi and then 1 over square root m. And what I'm trying to do here is I'm trying to bring all of the things that are constant into one place, and then I'm trying to make a relationship between the frequency and the square root m. And now what I can do is I can say that this entire constant, I can write it as x, and I can say F is equals to x over square root m. And then F times square root m is equals to x. Okay, and let's say this is the old frequency, and then this is the old mass. And now what happens is your new frequency is there, and then you have square root 2 times the old mass. Or you can just write it as m. I think that's totally fine as well. Let me just erase the old out. Okay, initially it's m, and then it's 2m, and then we have the old frequency, and then we have the new frequency that's there when the mass is going to double. So I hope that's clear. And both of them will be equals to x. Now what I can say, F new is equals F new square root 2m is equals to F old square root m. And then what I can do further is I can cancel out the square root m, and then I can get the new frequency is equals to the old frequency divided by square root 2. Okay, and the old frequency we can just say is F and then divide by square root 2. So your answer should be F divided by square root 2, which is B. Okay, question number 9 and 10. So they've given you a force against time graph, and then they've given you a bunch of other graphs below, and they want you to tell which is going to be the displacement time and the velocity time graph. So this is going to be a little bit of a unique question because they've given you force. You are probably used to seeing something like acceleration, velocity, and displacement and changing between those. The easiest trick to do this question is just knowing that this is actually kind of like a hidden acceleration time graph. Because actually, if you know, the Newton's second law, and if you can connect it with this question, it's very easy. F is directly proportional to A. So this is just a acceleration time graph, right? And now you just have to change this into a displacement time graph and a velocity time graph. Now, what I'll do first is I'll plot the displacement time graph and the displacement time graph. So the displacement time graph is anti-phase or 180 degree out of phase with the acceleration time graph. That's something you have to remember. So we're just going to flip this graph and then we're going to get, now this is a sin x graph, so we will get a minus sin x graph. So this is going to be the displacement and this is going to be time. We're going to get a graph that's going to look something like this. And that's going to be your answer D. Now from this graph, I can take the gradient of this graph and I can plot the velocity time graph. So here we go from max gradient to zero gradient. And remember, the gradient here will be negative. So we go from a negative gradient to 0. So it should be something like this. And then again, we go into a positive gradient. And then again, we go to 0. So positive gradient. And then again, we go to 0. And then again, we go to a negative gradient right over here. So 0 and then negative gradient. So it's going to look something like this, which is going to be a minus cos x graph, and that would be B. Okay, so with acceleration time graph and displacement time graph, you use this relation, and with displacement time graph and velocity time graph, you use their gradient relationship. The gradient of the displacement time graph is the velocity. Okay, so I hope that's clear, and now I will show you the mark scheme and the examiner report.